In this video, we explore how companies measure the P over Q rating for unmanned aerial vehicles, also known as UAV drones. The P over Q rating stands for performance divided by quality factors, and it helps stakeholders compare drones based on how much effective capability they deliver relative to reliability, cost, and safety measures. Understanding these factors is critical for optimizing design, manufacturing, and operations to achieve the best possible balance of abilities and trustworthiness. The first factor is payload capacity. Payload capacity describes how much weight a drone can carry, including cameras, sensors, or cargo. A higher payload capacity increases mission flexibility, but it also demands stronger motors and a more robust frame. Companies must balance payload capability against structural quality and safety margins to maintain a high P over Q rating. Next, flight endurance or flight time is the second factor. Flight endurance tells us how long a UAV can stay aloft on a single battery or fuel load. Greater endurance extends mission range and coverage, but heavier batteries and power management systems affect overall quality and system reliability. Efficient power electronics and energy control are essential. The third factor is operational range. Operational range is the maximum distance the drone can travel from its controller while maintaining a stable communication link. Longer range improves coverage for surveying, inspection, or delivery tasks, but it hinges on high-quality antennas, signal protocols, and anti-interference measures. Fourth is sensor and payload quality. The resolution, accuracy, and reliability of cameras, LiDAR, thermal imagers, and other payloads directly impact data quality and mission success. High-performance sensors boost capability, but add weight and cost. Robust calibration and integration processes ensure consistent results. Fifth factor is communication reliability. Reliable command and data links between the UAV and ground station are vital for safe operations. Encryption, redundancy, anti-jamming, and robust protocols define communication quality. Poor connectivity can degrade performance in critical missions. Sixth is aerodynamic efficiency. Efficient airframe design minimizes drag and maximizes lift, reducing power consumption and improving flight stability. Manufacturing tolerances, surface finish, and component alignment determine real-world aerodynamic performance. Seventh, manufacturing and build quality. Precision in assembly, material choice, and quality control impact durability and reliability. High build quality reduces failures and ensures consistent performance across each unit. Eighth is maintenance and support infrastructure. Availability of spare parts, ease of maintenance, and quality of technical support affect downtime and lifecycle performance. Efficient workflows and strong support networks sustain high P over Q ratings over time. Ninth and finally, regulatory compliance and safety certifications. Adhering to aviation rules, airworthiness standards, and incorporating fail-safe systems ensures drones can be operated legally and insured. Safety features and emergency recovery protocols boost quality as well as trust. Let's do a brief recap of the 9 factors that influence a company's P over Q rating for UAV drones. We examined payload capacity, flight endurance, operational range, sensor and payload quality, communication reliability, aerodynamic efficiency, manufacturing quality, maintenance and support, and regulatory compliance with safety. Balancing these factors leads to an optimal performance-to-quality ratio. Thank you for watching this in-depth look at UAV drone performance-to-quality ratings. If you found this video helpful, please like, share, and subscribe for more educational content on engineering, robotics, and technology. See you in the next lesson.